Hello guys! Today I will go through lesson 4. Applied encryption is for my class Web Security Associate. I am a little bit behind because I wasn't reading any chapters. I was busy, but I'm finally back. First part of the module 4 of the chapter 4 is creating trust relationships. So, applying encryption means establishing a trust relationship between hosts. This is exchanging a special piece of code called a key. The key allows to encrypt information so that the only one remote host can decrypt the information. This encryption is accomplished with public key encryption. This form of encryption demands that you create a private and public key. After you generate a key pair, so two keys, one public and one private, you can give the public key to anyone. Public keys are distributed using the following methods: manually or automatically. Manually, you have to first trade public keys with recipient, then encode messages to the recipient's public key. This is used for encrypting email messages between recipients, and automatically is used by secure socket layer and IP security. Okay, modern PKI, public key infrastructure, have been created to enable the automatic transfer of public keys. Okay, and here are the two concepts that are important for cryptography. A round is a discrete part of the encryption process. An algorithm generally submits information to several rounds. A higher number of rounds is preferable. Most symmetric key algorithm rounds first process half of the unencrypted data, then process the second half. Then each half is reprocessed to make the resulting encryption stronger. Separation of information into rounds makes symmetric keys faster. Discrete part of the encryption process. Parallelization. In regards to encryption, parallelization refers to two things. First, it can refer to the use of multiple processors, or machines to work on cracking one encryption algorithm. Individual hosts can be parallelized using a parallel cluster server. Such technology allows many different hosts to work together as one system, which helps to crack a piece of code. Parallelization can also refer to the use of application that is capable of using two algorithms at the same time to encrypt information. So parallelization can use two algorithms at the same time and crack the code. Rounds divides the code into halves, and which makes the process faster. Then it's reprocessed. And that makes the encryption stronger also. This is used for symmetric keys. It means there are two keys, public and private. Okay. In symmetric or single key encryption, one key is used to encrypt and decrypt messages. By using symmetric encryption algorithms, data is converted to a form that cannot be understood by anyone who does not possess the secret key to the crypt. The algorithm reverses its action so that the message is returned to its original and understandable form once the recipient has the key to the crypt. Even though single key encryption is a simple process, all parties must know and trust each other and have the confidential copies of the key to exchange the keys. Reaching this level of trust is not as simple as it may seem. The time when parties are trying to create trust is when a security breach can occur. The first time transmission of the key is crucial. If it is intercepted, the interceptor knows the key and confidential materials is no longer protected. Plain text input: Mary had a little lamp. Encryption with the key. This is the same key. Ciphertext encryption, decryption with the same key. Plain text. Okay. Benefits and drawbacks of symmetric key encryption. The main benefit of symmetric encryption over asymmetric encryption is that it is fast and efficient for large amounts of data. These features allow you to encrypt a large amount of information in less than a second. Disadvantage is the need to keep the key secret. This can be especially challenging where encryption and decryption take place in different locations, requiring the key to be moved safely between locations. So it can be intercepted, right? Therefore, all users must have a secure way to send and retrieve the key. If the symmetric key has to be encrypted itself, then why not use the method that encrypted it in the first place? One solution is to use asymmetric key encryption, a process that will be discussed later in the lesson. Okay, in addition to this concern, cyber attackers can compromise symmetric keys either with a dictionary program, password sniffing, or by looking through a desk, purse, or briefcase. Symmetric encryption is most likely to be defeated by brute force attacks. These types of attacks are discussed later. Dictionary program, a program specifically written to break into a password-protected system. A dictionary program has a relatively large list of common passwords, names that the program repeatedly uses to attempt to gain access. So the program uses all the long list of passwords to guess the encryption code. Next page. Symmetric algorithms. Numerous specific mathematical algorithms are applied to achieve symmetric encryption. These algorithms include the following: data encryption standard, DES, triple DES, Rivest, Shamir, Adelman, RSA algorithms, international data encryption algorithm, IDEA, Blowfish and Twofish, Skipjack, Mars, Rijndael, never heard of this one, Serpent, DES, data encryption standard, the U.S. National Institute of Standards and Technology, NIST, formally adopted DES in 1977. DES is a block cipher Another name for a data encryption standard is data encryption algorithm there. Okay. DES is a block cipher and encrypts data in blocks of size of 64-bit each, which means that 64 bits of plain text goes as the input to DES, data encryption standard, which produces 64 bits of cipher text. The same algorithm and key are used for encryption, decryption, with minor differences. The key length is 56 bits. So it can encrypt a block of size of 64-bit, but key length is 56 bits. This standard uses a technique called diffusion and confusion. The 64 block of data is divided into two halves, and each half is successively passed through the key called a round. DES has 16 rounds and the key is bitwise shifted for each round. 48 bits of the key are applied to the 32 bits of data for the round. The advantages of DES are that it is fast, simple to implement. DES has been in production use for more than 30 years. So many hardware and software implementations use the DES algorithm. However, key distribution and management are difficult because DES relies upon a single key model. Triple DES uses 56-bit key is considered sufficient for normal information. For sensitive information, some users employ a technique called triple DES or 3-DES. In this case, the message is first encrypted using a 56-bit DES key, then decrypted with another 56-bit key, and finally encrypted again with the original 56-bit key. Triple DES thus effectively has a 168-bit key. So it's 56 plus 56 plus 56 bit. Because of the several levels of encryption, triple DES also thwarts man in the middle. Normal DES is fast and triple DES is faster than other symmetric algorithms. The biggest advantage of triple DES is its ability to use existing DES software and hardware. Companies with large investments in the DES encryption algorithm can easily implement triple DES. Symmetric algorithms created by the RSA Security Corporation, Ron Rivest, Adi Shamir, and Leonard Adelman invented their public key encryption system in 1977 and named it after the first letters in their last names, RSA. Since then, they have gone on to invest several different algorithms. RSA algorithms are used in several commercial operating systems and programs including Windows and Microsoft Edge. RSA is one of the best known and most effective companies in the field of cryptography. RSA technologies are included in existing and proposed standards for the Internet and the World Wide Web. The RSA website, whose homepage is shown, is about cryptography and security. This course discusses only a few RSA contributions. RC2, RC4 are the most commonly used symmetric key algorithms. In commercial applications, they can use variable length keys up to 128 bits. RC, developed by Ron Rivest, stands for Rivest Cipher Number 2. It is a block Quote cipher, which means it encrypts messages in blocks 64 bits at a time because it is a variable length key. It can work with key lengths from 0 to infinity, and the encryption speed is independent of the key size. I'm not going to remember this. So RC4 encrypts 1 byte at a time. Number 5, RC5 this one takes any variable block sizes and key sizes. It's being simple, fast, and consumes less memory. RC6 is designed to remedy this weakness. What's the weakness? RC5 researchers noticed a theoretical weakness in how RC5 processed its encryption during specific rounds in the process. Okay, so RC6 is basically RC5 just patched with the patched vulnerability that it occurred in RC5. International Data Encryption Algorithm IDEA. It was called before PAS, Proposed Encryption Standard. It operates on 64-bit data blocks. The key is 128 bits long. Wait. 100. Okay. Even though many consider this as a strong algorithm, still it has not gained popularity. Blowfish and Twofish is a symmetric block cipher that can be used as a drop-in replacement for DES or IDEA. It takes a variable length key from 32 to 448 bits, so pretty big, making it ideal for both domestic and exportable use. Blowfish was designed by Bruce Schneier. Since then, it has been analyzed considerably and it is slowly gaining acceptance as a strong encryption. Twofish uses a 128-bit block. It's much faster than Blowfish. Twofish supports 128, 192, and 256-bit keys. It is said to be efficient both for software that runs in smaller processors, such as those in smart cards, and for embedding in hardware. It allows implementers to trade off encryption, speed, key setup time, and code size to balance. Skipjack is an encryption cipher designed by the US National Security Agency, NSA. The actual mathematical formula is top secret but is implemented in such products as a Forteza and Clipper chips. It uses an 80-bit key and 32 rounds on 64-bit blocks to accomplish its encryption. Mars is a block cipher algorithm introduced by IBM. It uses 128-bit blocks. Key sizes between 128 and 448. It is shared key symmetric. block cipher designed to take advantage of the power operations supported in today's computers, resulting in a much improved security performance trade-off over existing ciphers. As a result, Mars offers better security than triple DES while running significantly faster than single DES. Twofish, it is specifically designed to work well on smart cards. Oh, like Twofish. Riandel. Rindel. The Rindel or Deal algorithm has been adopted as a successor to data encryption standard. It allows the creation of the keys in any multiple of 32 bits with minimum of 128 bits and a maximum of 256 bits. It is a block cipher. The developers were especially interested in making an algorithm that could perform quickly on various platforms, including ATM networks, integrated services, digital network, and high-definition television. Serpent has a block size of 128 bits and supports a key size of 128, 192, and 256. Although much more advanced, Serpent is somewhat comparable to this. Additional algorithms: Misty 1, Misty 2, developed by Mitsubishi, uses 64-bit block with a 128-bit key. Ghost, first developed by researchers, Soviet Union. This algorithm is 64 bits, uses 256-bit key. It is a block cipher algorithm that is very similar in structure to this. Cast 256. This algorithm is a block cipher that uses 64-bit blocks and key sizes in any multiple of 32 bits with a minimum of 128 bits and a maximum of 256. The original cast algorithm uses 64. Any of the previously mentioned algorithms can be used for symmetric encryption. Each presents advantages and disadvantages ranging from susceptibility to defeat to royalty costs for using the algorithm. Remember that both parties involved in the encryption must agree ahead of time which symmetric algorithm will be used. Advanced Encryption Standard AES is the encryption standard used by the US government. In January 1997, NIST began the process of determining an AES successor to DES because most security experts believed that DES and triple DES no longer met security requirements. Among other requirements, the symmetric algorithm chosen for AES had to allow the creation of 128-bit, 192, 256 keys, provide support for various platforms, smart cards, 8-bit, 32-bit, 64-bit processors, and be as fast as possible. The AES finalist candidate algorithms include the following: Mars, RC6, Riandel, Serpent, Twofish. Riandel was announced as the winner to become AES by NIST. Security expert lead that. I am lost. I have to ask. Wait. I cannot copy this, or I can. Well, let's see. No, it doesn't copy. Huh, okay, no worries. Ah! I will take a screenshot then, because I'm lost. And I will ask ChatGPT. So, AES is an algorithm. So what do they mean by saying that IS finalists were different algorithms? So what AES finalists means? So they NIST ran a global competition. So the NIST said, submit your best encryption. Cryptographers from around the world submitted designs. NIST reviewed them and narrowed them down to five finalists, which are these. And each of these was a completely different algorithm designed by different teams. So what is AES? Is the name of the winner. So Riando was the winner, and that one was called AES. Okay, so this wasn't a new created algorithm. This was just renamed Advanced Encryption Standard. That's why I get confused. Did they mention that they created a competition, or did they skip something? Okay. Okay, here is the lab. We are not going to do any labs. I'm focusing today on reading the chapters. One-way hash encryption. Hash encryption, also called one-way encryption, converts a document or information of variable length into scrambled 128-bit piece of code. A malicious third party cannot re-engineer the hash through a hash algorithm to decrypt a password. When a user enters a password to access a secure website or intranet, the password is encrypted and compared to the stored hash password in the web server. If the values match, then access is permitted. Once the password is hashed, the process cannot be reversed. So hash is a one-way encryption. Signing data. Signing is normally implemented by passing the data to be signed through a one-way encryption algorithm. Signing is often accomplished by using hash encryption, which creates a hash value that is unique to the specific piece of data from which it was generated. Hash is unique and extremely depends upon the contents of the message. Changing the message result in a different hash. The person who wants to sign the data now only has to encrypt the hash value to ensure that the data originated from the sender. And the form of signing provides security mechanisms, authentication, data integrity. Okay, hash algorithms. Ron Rivest also developed a cryptographic hash functions named MD2, MD4, MD5 Rivest's design goals for the MD series are security, speed, and simplicity. They also favor the Intel processors as opposed to Unix. The normal message digest is 128 bits long. MD2, MD4, MD5 algorithms belong to a group of one-way hash functions. These functions take any length of byte stream and generate a unique fingerprint of a certain length. You cannot generate the message back if it's hashed. It's one way only. MD2 is an easier 8-bit version of the MD5 algorithm, which is used to verify data integrity through the creation of a 128-bit message digest from data input, which may be a message of any length. MD4 produces a 128-bit hash. Secure hash algorithm, SHA, is another hash function, also known as Secure Hash Standard, SHS. It was developed by NIST and NSA and is used in the US government. It produces message digests that are 25% longer than MD4 or MD5. SHA is longer. Okay, this is not that important right now for me to remember. This is some kind of lab, I guess. Is this a lab? What is this? You can issue the following comment. Host MD5 some user has been named. The text string immediately beneath the MD5 sum comment is the 128-bit hash of the user has been named file. You can save this output into a file, in this case named MD5. Now let's check. Wait. Oh, it's so small. Okay. I cannot. Okay, I guess this is the start. MD4, an earlier 8-bit version, identify incorrect terms. So MD2 was 8-bit, not MD4. Is an algorithm used to verify data integrity through the creation of 128-bit message digest from data input that is claimed to be unique to that specific data. The SHA is a hash function that produces from an arbitrary length string. SHA is structurally similarly to and it's 25% longer. Let's see what else. Correct answer. MD4, 128. MD2 and AD2. Okay. Let's retry. So here should be MD2. It's not 128. And here, okay. So MD2 is an earlier 8-bit version of MD5. Is an algorithm used to verify data integrity through the creation of a 128-bit message digest from data input that is claimed to be as unique to that specific data. The SHA is a hash function that produces a 160-bit hash value from an arbitrary length string. SHA is structurally similar to MD4 and MD5. Although it is about 25% slower than MD5, it is much more secure. Okay, next page. Asymmetric key. Asymmetric encryption is public key encryption. It also uses a key pair. A key pair is a mathematically matched key set in which one half of the pair encrypts and other half decrypts. Let's see it. Oh, so plain text. Welcome to the National DRSA top secret encryption public key ciphertext decryption. Benefits and drawbacks of asymmetric key. It is so difficult and time consuming that is practically impossible determining the value of the private key from the public key. From communication over the internet, the asymmetric key system makes key management easier because the public key can be distributed while the private key stays secure. One of the drawbacks of asymmetric key encryption is that it is quite slow due to the intensive mathematical calculations that the program requires. If a user wanted even a rudimentary level of asymmetric encryption, hours would be needed to encrypt a relatively small amount of information. You have probably used a web browser to conduct e-commerce transaction. It has become standard to encrypt such transactions using the secure second layer protocol. Most web browsers already contain certificates from trusted certificate authorities. After your web browser recognizes that the web server's certificate has been signed by a trusted authority, the SSL session is granted automatically as long as the browser verifies that the key certificate has been signed by a trusted authority. The web server has the same name as given in the certificate. If any of these checks fails, most web browsers will warn you and ask if you want to proceed. Three most common asymmetric key elements are RSA, digital signature algorithm, and Diffie-Hellman. Once again, I need to ask chat the difference between symmetric encryption and So symmetric encryption uses one key, which encrypt and decrypt. Asymmetric key uses two keys, public and private. So symmetric algorithm. Symmetric algorithms use one key. So RSA uses one key. But it says that's why I'm confused. Wow. So ChatGPT says this is incorrect, that symmetric algorithms lists RSA here as a symmetric encryption. That is not true. It says the correct classification, the symmetric algorithm, DES, triple DES, IDEA, Blowfish, Twofish, Riandel, which is advanced encryption standard, Serpent, Mars. Asymmetric algorithms, 2 keys is for RSA. Wow. So the book is wrong. That's why I was confused. Yes, symmetric uses 1 key. And it also said that it uses a pair of keys, even though single key encryption is a simple process. Okay. Applied encryption. No, we were here. Yep. Yes, so asymmetric key uses 2 keys, public and private. Anyone who intercepts the secret cannot decrypt it without receiver's private key. Benefits and drawbacks of asymmetric key. Okay, I read this already. One of the drawbacks of asymmetric key encryption is that it's quite slow due to the intense mathematical calculations. Okay. Asymmetric keys are RSA, digital signature algorithm, Diffie-Hellman. Okay, RSA, Rivest Shamir Adelman. The most widely used asymmetric algorithm is embedded in the SSL secure socket layer and TSL transport socket layer or security layer protocols, which are used to provide communication security over a computer network. RSA derives its security from the computational difficulty of factoring large integers that are the product of 2 large prime numbers. It is one of the first public key crypto systems and is widely used for secure data transmission. It is an algorithm that uses a key based on a pair of very large prime numbers. The key sizes used by RSA are 1024 bits, 2048 bits, and 4096. So ones, double, triple. Yeah. 1, 2. It's 1024 times 2 and then 2048 times 2. Digital signature algorithm, DSA, was introduced by NIST. So this is a digital signature algorithm. It's available openly. It is used to sign documents. It's available openly. Does it mean it's free? DSA, it says it is open. Yes, it is free. Okay. Although it functions differently from RSA, it is not proprietary and has been adopted as the standard signing method in GNU Privacy Guard (GPG), which is the open source alternative to pretty good privacy. The DSA digital signature algorithm works in the framework of public key crypto systems and is based on the algebraic properties of modular exponentiation together with the discrete logarithm problem, which is considered to be computationally intractable. What is computational intractable in simple words? Let's see. Too hard to solve in a realistic amount of time. A problem is computationally intractable when it can be solved in theory, but in practice it would take years, millions of years, or longer than the age of the universe. Okay. Logarithm versus algorithm differences. I want to know. Algorithm, a set of steps or instructions to solve a problem. Used in programming, cybersecurity, networking, sorting numbers, encrypting data. A logarithm, a math operation. It answers what power do I raise a number to get another number. Okay. So algorithm is instructions and logarithm math calculations. Diffie-Hellman key exchange algorithm is a method for securely exchanging cryptographic keys over a public communication channels. Keys are not actually exchanged. They are jointly derived. It is named after its inventors, Diffie and Martin Hellman. It provides a secure exchange of keys, thus it is known as a key exchange protocol. It is not an encryption algorithm per se because it does not scramble text. It is an open standard and has been widely adopted by the security community with only one major change. Was at one time especially prone to man-in-the-middle attacks. The station-to-station STS protocol alters the Diffie-Hellman protocol to include proper authentication. Knowledge check. An algorithm that works in the framework of public key crypto systems. This is the digital. This is the free one, open source. A method for securely exchanging cryptographic key over a public communication channel. This is Diffie-Hellman. An algorithm that is embedded in the SSL, TSL protocols, which are used to provide communication security over computer network. RSA. Okay. Oh, one more? No. Next page. Encryption methods are used in a wide variety of applications: virtual private network, which is a private connection for people who want to use a corporate network from different place than the office. It's a one-way encryption, asymmetric combination of symmetric, asymmetric, and one-way encryption. Internet Information Services, Netscape, Suite, Spot, Pretty Good Privacy, Exchange Server, Windows Server, all employ a combination of symmetric and asymmetric and hash encryption methods such as VPN, secure HTTP, email. The following is step-by-step account of the encryption process that was outlined. The sender and receiver need to obtain each other's public keys. An email message is sent. The sender generates a random session key that will be used to encrypt the email message and attachments. This key is typically generated with respect to time and some randomness, such as file size or date. Algorithm used for the encryption is DES, triple DES, IDEA, Blowfish, Skipjack, RC5. The sender will then pass the session key message through one-way encryption. This value provides data integrity, so the message is not altered in transit. Hash. The algorithm used at this step is MD245 SHA1. MD5 is used with SSL. SHA is default with SMIME. The sender then encrypts the hash value with his private key by using the sender's private key. The receiver is certain that the message could have originated only from the sender. The encrypted hash value is called the message digest. The sender then encrypts the email, message, and any attachments with the random session key that was generated in step 2. Step 2, the key is typically, the key. This encryption provides data confidentiality. The sender then encrypts the session key with the receiver's public key to ensure that the message can be decrypted only with the receiver's corresponding private key. This provision provides authentication. The encrypted message and message digest are sent to the receiver. The decryption process occurs in the reverse order of the encryption process. Asymmetric key encryption. Encrypted with the key, signature, and then decryption. Encrypted, Alicia, public, private. Message. Here are 3 different types of messages. Encrypted, symmetric key, decrypted with private key, right? With B, random symmetric key, encrypted text, and signature, decrypted with Bob's public key. Wait, so sometimes they use, so I will ask chat, so sometimes they use public or private to decrypt? I thought it's always like private. Yes, it feels confusing at first. So case 1 uses public to private, and then Bob encrypts using Alicia's public key. And then case 2, digital signature, which is here. Uses private to public. Why it looks like public decrypts? It's not really decryption in the normal sense. When using private to public, private to public, that's signature verification, not secret decryption. That's signature verification. Public key encrypts, private key decrypts. Public key encrypts. Okay, private key signs, public key verifies. Okay, that's why. So public key always verifies. Okay. Oh gosh, this chapter is whoa, so long. Pretty good privacy and GNU Privacy Guard. Perhaps the most popular technology encryption programs for email and text files are Pretty Good Privacy and GNU Privacy Guard. They are both successful because they exploit the advantages of symmetric and asymmetric encryption. GNU Privacy Guard was originally designed for Unix systems and is available. The remainder of this discussion applies to both applications. Upon installation, Pretty Good Privacy and GNU Privacy Guard generate a public key and private key. However, as outlined above, this pair is an asymmetric key and should be considered two halves of one whole. The two halves are, in effect, two sides of the same coin. For example, the following code represents a public key as generated by PGP. This code represents one half asymmetric code. To ensure greater security, they use a simple symmetric code. Besides generating the public and private keys, PGP and GPG also ask you to create a simple, memorable password that protects the asymmetric key pair, which is a form of symmetric encryption. In this way, both PGP and GPG create a powerful encryption system that is easy to use and that operates quickly and efficiently. The actual message is encrypted with a random symmetric key, which is then encrypted with the recipient's public key. Finally, both PGP and GPG use hash code in that they create a ciphertext signature that can be compared without divulging the actual information that created the key. You can begin generating a revocation certificate in PGP by highlighting your key and posting the revocation to a certificate server. You should always create a revocation certificate when you generate a key. Under ideal conditions, you will never have to use this certificate. However, it is necessary because in case of compromise, it allows you to quickly publish the fact that the key pair is no longer valid. Sometimes these certificates are contained in a central location known as a certificate revocation list. GPG will then generate a revocation certificate after you give the password for your private key. You can then publish the revocation certificate when necessary in the following lab. Okay, we are not going to do any labs. Any labs. Secure sockets layer and secure HTTP each allow spontaneous encryption. They are often used in web, email, and network news transfer protocol (NNTP) servers to help secure transactions and communications. Additional applications used in the security community also support SSL like PGP. Both secure HTTP and SSL use symmetric, asymmetric, and one-way encryption. They then use one-way encryption to sign all the data packets. Practical use of asymmetric key encryption. It is vital to understand that asymmetric key encryption does not encrypt the entire message. So, to use asymmetric key encryption this way would require too much time. It is more data intensive than symmetric key. Thus, it requires more processor time. Therefore, asymmetric key encryption is used to encrypt only the symmetric key. The asymmetric key is not used to encrypt all of the data packet or all of an email message. Using asymmetric key encryption to encrypt only the symmetric key results in fast processing times as well as adequately high security. Secure HTTP uses the asymmetric process to secure online transactions, but as soon as this connection is made, it uses a symmetric key. Most browsers support this protocol, including Mozilla, Firefox, and Edge. The client generates a unique session key. The client encrypts the session key with the server's public key network. The client sends the encrypted session key to the server, then private key server. The server uses its private key to decrypt the session key, and then the server and the client now have the same session key. Transport layer security. So asymmetric encryption doesn't encrypt the whole message. So RSA encrypt data directly. So technically you could encrypt a whole message. Why we usually don't do that? Because asymmetric encryption is slow, limited in size, computationally expensive. What happens in real life? This is the key. We use hybrid approach. Generate a random symmetric key by advanced encryption standard. Encrypt the actual message with AES fast. Encrypt the AES key with RSA. Message encrypted with AES key encrypted with RSA. Easy analogy. RSA secure enveloped for the key. AES fast lock for the actual message. One line answer. Asymmetric encryption usually protects the key, not the whole message. Okay. Transport layer security and secure sockets layer. The transport layer security protocol and its predecessor SSL allow applications to exchange data over public network privately, thereby preventing eavesdropping, tampering, and message forgery. There are slight differences between SSL and TLS, but they are essentially the same. TLS 1.0 is an Internet Engineering Task Force specification. The previous version, TLS 1.2, was defined defined in RFC 5246. Okay, I don't have to remember this. That's too much. In some ways, TSL and SSL might be more secure than other methods because the encryption process takes place at a lower level of the network according to the Open Systems Interconnection OSI model. Open Systems Interconnection OSI model. Open System Interconnection. Knowledge check. Steps of the encryption. The sender encrypts the session key with the receivers. The sender generates a random session key that will be used to encrypt. The sender encrypts the session key with the receiver's public key to ensure that the message can be decrypted only with the receiver. The encrypted message and message digest are sent to the receiver. The sender encrypts the email. The sender and receiver need to obtain each other's public keys before an email message is sent. So first they generate a random session key. Then they need to exchange the key. Then the sender encrypts the session. Then the message digests are sent to the receiver. I will just move this just to make it blue. The sender encrypts the email message and any attachments. Wait. Passes the session key. Okay, I don't know. I will check. What did I do wrong? Correct answer. The sender and receiver need to so this is first. Oh. Okay, and then they generate the key. Passes the session key. I cannot change. Reset. So first the sender and receiver needs to obtain. Then the sender generates the key. Then the sender encrypts the session. The sender message digest. The sender passes the key. This is the last one. Okay, I will. I know I was close. Okay, those two. The sender passes. This is the correct. The sender passes the session key and messages through one-way encryption. The sender passes. Okay, so encryption with the key is like the last step. Okay. Okay, the sender and receiver need to obtain each other's public key. Then the sender generates a random session. The sender, this is here. The sender passes the session key and message through one-way encryption to obtain a hash. Then the sender encrypts the email message and any attachments with the random session key. The sender encrypts the session key with the receiver's public key to ensure that the message can be decrypted only with the receiver's corresponding private key, and then the message is sent. Ooh. Encryption review. Encryption, a process that scrambles and unscrambles data. Authentication, a process that establishes participants' identities using the principles of authentication. What you know, what you have, who you are, where you are. Key, a word, phrase, or string of text used to encrypt and decrypt. Symmetric key, private key encryption. An encryption method that uses only one key. Asymmetric encryption method that uses two keys. With one key can be decrypted using the other key. Message integrity by hash mark and signature, a concept that uses one-way algorithm and generate a hash value that is computationally unique, ensures that the message or data is not tampered with after it has been sent. Knowledge check, one more. Asymmetric key encryption method uses one key, so this is a symmetric key. Encryption method that uses two keys, asymmetric. A word, phrase, or string of a text that can be used to encrypt and decrypt information. Encryption, a process that scrambles and unscrambles data traveling through the network. Key, a word, phrase, or string. Okay, submit. Awesome. Certification authority provides identification and trust in an e-commerce system. It is an entity in a network that manages security credentials and public keys for message encryption. It issues digital certificates that confirms the identity and other attributes of certificate in a relation to other entities. Digital certificates are data files used to cryptographically link an entity with a public key. Certificate authorities are a critical part of the Internet's public key infrastructure because they issue the secure second layer that web browsers use to authenticate content sent from web servers. Digital certificates, also known as public key certificates, to obtain a digital certificate, you must apply to a trusted certificate authority. The applicant must create a private key and provide a significant signing request CSR to the certificate authority. Depending on the type of certificate involved, the CA will verify the applicant's identity in some manner, which might be as simple as verifying an email account on that domain, but could involve the verification of public company documents or even personal interview. Let's see. Private key is made and certificate signing request is sent to certificate authority. Here, certification authority verifies identity of user, then it sends a certificate with certification authority's public key. Then 3. Certification authority's public key is used to decrypt the certificate and verify its authenticity. A reply is then encrypted with the certification authority's public key and returned. Step number 5. Certification authority uses its private key to decrypt the response, obtaining symmetric public key. So private key, signing the certificate, then certificate authority verifies everything and sends the certificate back with a public key. Then public key is used to decrypt and verify its authenticity. And reply is then encrypted with the authority's public key again. Certification authority uses its private key to decrypt the response, obtaining private, public, public, private. Oh boy. Private key infrastructure supports the distribution of these public keys and certificates to enable trusted connection and secure data exchange based on the information from the CA signer. Software such as web browser may contain CA keys to facilitate the handling of certificates. Online certificate status protocol to query for revoked certificates. Increasingly, browsers are employing online certificate status protocol. Extended validation certificate. There are 3 types of certificates that offer 3 levels of user trust for SSL/TLS negotiations: domain validated certificates, organization validated certificate, and extended validation certificate. And level of trusted certificates include extended validation, provide the highest level of assurance that the certificate authority has validated the entity requesting the certificate. It spells out the detailed requirements for the process that certificate authorities must apply when verifying information provided by the applicant for an EV certificate. Organization validated certificate provide the next highest level of assurance. Checking of the applicants. Domain validated certificates require only that the applicant demonstrates ownership of the domain for which the certificate is being requested. Let's Encrypt. The Linux Foundation collaborated with the Internet Security Research Group to create Let's Encrypt. It gives your site a free domain validated SSL certification, and you can set it up to automatically renew. That's nice. This is for free. Cool. Oh, I can color this. Save. Ha. Okay, Let's Encrypt. Remember this. You can use this to get your site a free domain validated SSL/TLS. Can we check that? It's free, automated, and open certificate. Okay. I can save this website. I can save this website to OS. Okay. CA CERT, Free Certificate Authority, has a variety of free SSL TLS certificate available, but you do have to meet with a CA CERT volunteer face-to-face to review your government issued identity. Komodo. If you want to experiment with SSL, Komodo offers you 90 days of free. Cloudflare. This is not going to be free. It's very user-friendly. SSL.com is another 90 days free. SSL for free is another site that gives you a free. It runs on Let's Encrypt. Start. If you have a personal website or a blog, will give you one unlimited domain validated certificate completely free. All you need to do to get this free is to validate that you own the domain. WallSign is another very user-friendly site that gives you domain free SSL. The certifications are good for 2 years before you have to renew them. They use automatic authentication, so they are up and running in a few minutes. Okay, knowledge check provides the second highest. The second highest was DV, I guess. No, organization validated. Whoa, what happened? I wanted to take a screenshot. To know what's the difference between those three in short. EV, highest trust, medium, OV, medium trust, DV, lowest trust. Okay. Second is OV. Requires that the applicant demonstrates ownership of the domain for which the certificate is being requested. DV, and provides the highest level of assurance. EV, extended. EV, who you are, strong proof. OV, you are a real businessman. And 3, DV, you control the website. Okay, submit. Full whole disk encryption. Advantages: full disk encryption, FDE. Advantages: everything on the drive is encrypted, including temporary files. Some FDE programs can cause an increase in data access time. Case to study. The FDE method only encrypts every file stored on the drive except the temporary. False. What? Oh. Encryption of data is forced on end users, alleviating decision on what not to encrypt. True. Wait. If a user loses his password that grants access to the encrypted system, he can still access his data through email. I'm not sure. True? I'm not sure. FDE does not necessarily protect data on a laptop if the system is compromised. Let's go with this, and if you use it, if a user loses his password that grants access to the encrypted system, he can still access his data through email. No, that's false. Of course that's false. I'm just tired. Okay. Whoa! Summary. We survived! Application project. In this lesson you learned blah 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 blah. Marcus read. Okay. What's next? This is some labs. Glossary. Dictionary program, password sniffing, virtual private network, secure HTTP, an organization that determines the standards and protocols for the internet. Secure MIME, a public industry standard method for public key encryption and email signing. Industry standard method. Encryption, a process that scrambles and unscrambles data. Public key encryption, as MIME, public key encryption. Authentication, a process that establishes participants' identities using the principles of authentication. What you know, what you have, who you are. Who you are should be first. It's like the basic question. Who you are. Authenticate. Certificate authority, a trusted entity that issues digital certificates, which are data files used to cryptographically link an entity with the public key. Yep. Types of attacks. This is the next one. Okay, for today, that's all. Thanks. See you next time.